So as we discussed last time, we have started with overall, statistics. We try to understand a couple of terms, and these terms are basically, asked in the interview, right? Okay, this is the way the normal data life cycle for a given data scientist. There could be addition or subtraction of steps. This is just the generic data, cycle. We start with overall understanding the business requirement for the requirement. We try to acquire the data, then we try to process the data as need of the solution. So we align the data as per the need of the solution. We try to extract whatever is needed for the solution out of the big chunk of data. And then we build a model based solution, and then we try to develop, construct, and then we deploy the model as per the need. And we normally try to automate the deployment process. Okay. Any questions? I know everybody can explain in their own, means and ways as far as data lifecycle solutioning goes. But overall, mota, there's a gist, right? Any confusion so far? Any query for me?
No, we are okay.
No. Yeah.
Okay, great. So we started, what we normally do with data. So we collect, we measure, we analyze. We also build some report visualization. We try to understand the data from the, definition given in couple of, different these things. So data are sometimes said to be transformed into information when they are viewed in the context of a post analysis. So data in reference with the other environmental factors gives us a clear inference of or clear information or details of a certain perspectives. Then we have qualitative, quantitative data. Qualitative data is normally can be, quality, good, bad, ugly. Then we have quantitative data, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. In qualitative data, we normally have a nominal data where we normally have a categorization of certain elements like male, female, as is shown in the picture. In ordinal data, we have ordinal series normally. So we normally have something like good, average, ugly, and we try to basically group into them. Okay. Then we see quantitative data, number of students in a class, weight of a person. There's a discrete data where we try to basically draw an inference on a given data. In terms of continuous data, it's a continuously reproducing data, and most of the solutions are normally fall into this category as well. So we try to basically group this data depending upon time, depending upon some categorization, depending upon some need of a business differentiations within themselves. Okay, so those kind of scenarios, the continuous data. Then we had a look at statistic, how we're going to do these things on a practical level, right? So we try to understand how statistics helps us in terms of to categorize this data better. What do you mean by sampling? What is population? This is a generic, terminology used all over in data scientist or statistic and probabilistical discussions. So population, anything. Population can be population of car, population of people, population of a fish, anything. And then sample is a subset of that population which we choose to analyze. It's called sample. Okay. Then there are various techniques in sampling. We talked about probability techniques, non-probability techniques. We have randoms, star field, systematic. Then we have snowball, convenience, judgment, and quota. These are different type of sampling we normally apply for different type of solution giving, right? And we try to basically review these samplings one after the other. Then today we're going to understand what is descriptive statistics. Now, descriptive statistics use the data to provide description of a population, either through numerical or graphicals. Let's try to understand when we say there's a 2 million population stays in Midwest, which is a Bible Belt. It's a simple statement to state out, but to make that statement, there's a lots and lots of studies going on. So we need to understand how they've calculated the population, and they have not mentioned about the age, range, which are the elders, in larger number, the youngers are in larger number or the kids are in larger number and so on and so forth. So for these things, we need to take a deep dive. But overall, to give a statement in terms of inferential statement, we need to understand the descriptions of the data provided with the data. And we might need to verify quite a few sometimes depending upon need of the solutions. Just to make sure whatever we have to got it cleaned, aligned, and then filtered as per the need. So that's our first few process. For that matter, descriptive statistics help us a lot. In descriptive statistics, we normally start categorizing the data in a group, something like maximum, average, minimum. See, there are just three categories here, right? But when you talk about a general population in terms of cars, there are various different colors. There are various different CC range or the power of the car, the driving or pull-up power of the car capacity. Different groups on number of per gallon miles per gallon kind of scenarios. Or nowadays we have electrical car, gas car, and a hybrid car, and so on and so forth. So we need to able to categorize cars on these 5-6 terminologies. Same way, descriptive statistics is mainly focused on main characteristics of the data. It provides graphical summary of the data. So when you talk about car population, descriptive statistics clearly give you what you mean by car. So car definition has been included in the even if somebody knows and somebody read, you need to include these things. So what type of population are we considering here? It can be people population, like it can be population of the humans, in a given region. So we need to understand what is human population, what is a given region we are talking about. So there should be some mention and understanding of those terminologies which are included inside the data given to you. So descriptive statistics, again I repeat, is mainly focused on main characteristics of data. It provides graphical summary of a data. And after we analyze them, we can basically give a graphical summary, basically good detail. So we can start studying the data. So it's a kind of first step when you talk about descriptive statistics. To take a step further, we have inferential statistics. Inferential statistics makes inferences and predictions about a population based on sample of data taken from a population questions. So when you talk about like the t-shirt examples we discussed earlier, like we talk about how many large, medium, or small t-shirts I need to order for a given class. Now here, when I try to make a statement, when I try to infer something, I try to basically categorize the population based on some samples, based on some conditions I have created to categorize that population. Inferential statistics generalizes a large data set and applies probability to draw conclusion. Sometimes we use probability if you have historical facts with you. Sometimes you normally try to predict this probability or extrapolate this probability. So we take a sample and then we extrapolate this probability. It allows us to infer the data parameter based on a statistical model using sample data. So here what I'm doing, I am gaining some sample data, and from the sample data, I'm analyzing how many large, medium, small, and then I'm extrapolating the data to make sure I'm in line with the actual population scenario, or I'm assuming that the sample which I am studying is a representation of the bigger chunk of the data or the complete analysis of the given population. Now, depending upon your solution creative capability, we need to understand how we withdraw sample. And there are different type of statistical techniques we, as we seen in sampling, we apply to them. Right now, one doesn't fit all, because there is we need to choose from something like time consumptions, something like the samples we can handle, something like what type of quality, quantity, even the spendings or the economics of the solutions as well. So there are quite a few aspects for choosing a sampling in a given scenario. So as a data scientist, we need to understand these things. We need to understand the data at hand. We need to understand the limitation at hand. We need to understand which type of techniques is more suitable to your solution. And this is how a data scientist start conceptualizing the solution for it. Let me show you a typical, video where it's a very small video where we try to understand how descriptive and inferential statistics differ from each other. Okay, give me a minute. I'll stop share. Okay, this one. I'll go here. Oh, come on. I'll just pause this thing. Video, because watching the video and writing down, you will remember the concept. There's a bit of difference, as you know, the trainer have said. The differences are important, and normally interviewers or whenever you start working, they try to pressurize with you the with these terminology know-hows and the other descriptive part of it. So knowing those things, I'll not say by heart, but at least understanding those things conceptual wise is a kind of need of the hour as far as data scientist goes. That's what makes us scientists, right? In terms of scientific or engineering approaches giving to your solutions. So these type of tools or these type of differentiation of sampling data or statistical method which you're going to apply to a solution and will be able to describe those things is a really plus point in a given scenario. Okay, let's try to understand how do we go about it. Descriptive statistics broken into two categories: measure of central tendencies and measure of speed. Now what we are trying to do, we are trying to understand how the population is spread. So there are two different ways: central tendency and variability spread. So these two terminologies are really important to understand. Central tendencies, we normally call it measure of center. We normally use mean, median, and mode type of mathematical formulas to apply to this measure of centers. In variability spread, we have some different formulas. Okay, these three are really simple and easy to understand. Let's first try to start with the simplest one, and then we basically venture into the difficult one. Okay, let's try a step by step way. So measure of spread. In measure of spread, we have range, interquartile range, variance, and standard deviation. All these, 5, 8 different, what you can say, statistical categories are simple enough if you understand. If you understand these things once and for all, there'll be no confusion and nobody can confuse you. So for that, we need to understand how these, spread or categorization of a statistical populations happens on the ground for a given solution, for a given type of data at hand. Okay, let's try to understand mean. We have used mean in our 8th, 10th, 9th standard, depending upon your education and curriculum given to you, right? Let's take an example. We want to find an average horsepowers of a car among the population of a car. Okay, and measure of average of all these value in a sample is called mean. Let's try to understand how do we do it. Okay, as the table shows, we have around 3, 3, 6, 9 cars there, right? The miles per gallon given in a column, cylinders given in a column, displacement, horsepower, I don't know what that's, but that, whatever they call it. Okay, let's try to understand. Our main concern, we are trying to understand the average horsepower. So horsepower is HP we are talking about. So in a horsepower, how do you calculate average? You will add all these 9 elements and divide it by 9. Oh, are they 8? 3, 3, 3? No, there are 9. Okay, 1, 2, 3, 100, 193, 96, 90, and 310. It should be divided by 9, right? Am I, reading something wrong?
No, it's only 8 only. Yeah, sorry.
1, 2,
There are
3,
8 values, yes.
6, 7. Okay, so there are 8 entities. Okay, I was confused. So I will pardon me for that. So 8. So the mean is we just average it out. But in a real statistical sense, averaging it bit different. Here, they represent a mean. So mean of all horsepower in a table is sum of all horsepower element and divided by number of horsepower element. So we can say n1, n2, n3, n4 divided by, sorry, n1 plus n2 plus n3 plus n4 dot divided by n equal to mean. That's the standard mathematical formula we use. Okay, any confusion in understanding mean?
No, I'm fine.
Very good, right? Simple one. Now median. Now how do we call median? So in median, we are trying to come up with center value. So if our value, fluctuates between 90 to 110, right? Here, rather than going by number of these things, what we do, we add these two and divided by, or we try to get a median out of these data values. How do we do it? In case of even entries, take average of the two middle values, that is 22.8 plus 23 divided by 2, 22.9. These guys are basically trying to find a median amongst miles per gallon. So miles per gallon deviates between 21 to 23, right? So here what we trying to do, we are trying to even entries take average of two middle values, that is 22.8 plus 23 divided by 2, that gives us 22.9. So 22.9 is our median. We'll do it programmatically. Don't worry. I believe you'll understand then. And there's a mode to find the most common type of cylinder among the population of car. Check the value which is repeated most of the time. So it's a cylinder type 6. So there are number of 1, 2, 3, 4, 5. 5 car models are of 6 cylinder and 3 of 4 cylinder, right? So here what we are trying to do, we are trying to basically find a mode out of the given data. So it's simply you just calculate it and there's a formula for it. We can apply Python based formula. I'll tell you, I'll share the program also with you. Okay, before that, let's try to understand how statistics help data scientists. Okay, let me statistics for data scientist. Oh, come on. Give me a minute. Let me share this video for you. Okay, so I'm so let's try to understand, how we can do or how we can generate mean in Python. If you can see on the screen, we have basically created a dictionary with just 5 numbers. We try to understand length from the length of the dictionary. Then we basically just apply, sum of all numbers within that dictionary, depending upon them. And after that, we basically apply a function called mean. So it's as simple as that when you process mean within Python. Okay, so let me load that this thing for you. It's called mean most probably, right? Oh, come on. What's that? Yes. Oh, sorry, I have to share this thing, right? So let me share my spider. Yeah. Could you see spider on the screen?
Yes.
Yes, sir. Yeah.
So it's as simple as that. There are just, a 3-line program. We basically created a variable with dictionary. You can use whatever you have. We have, len as a function. I'm, getting len in n. I'm just summing the complete, dictionary. And after summing dictionary, I'm trying to get mean with sum divided by n. Okay, let me try to play this. So the average is so and so. I can round it off if there's a need. I can change the variable if I want from this thing. Let me put 1 0 and instead of 1 to 2, twice I'll have how much? Let's say 190. Okay, so I've just changed a couple of value. The spacing basically should be good, and I'll run it again. So see, the overall average is mean or average is changed. So mean or average, these normally also used interchangeably. Any question here? Simple program, right? Any confusion?
No, we are fine.
Okay. Let me mean mode, right? Oh, come on. I might have kept it open, but that's okay. Mean, median, and then I'll also open mode one. I created these, three programs, so I'll share them with you. It's not that difficult. Mean, median, and base mode. Oh, I couldn't find the mode one. Come on. Okay, let it be, no problem. Let's start with this median now. So we have a number, we have num, and then I'm using extra method called sort. So I'm sorting the modes because as the mode, the mode, I need to understand the repetitions and everything, right? So for that, I'm sorting it out one by one, and then we basically dumping it in a dictionary, and I'm just using median on that dictionary after sorting it out. Okay, so this is the median is 4 for all these things. If you see, if I change it to, let's say, let's do some changes. Let's make it 42. Let's make it 36. I'm trying to, and instead of 4, I'll have how much? Let's say 12. Oh, sorry, comma. Instead of 5, I have 50. But I've just changed the number and I'm running it again. So the median is 12 now. I have increased the latter part of it, and that's how the median is changed from 4 to 12. Okay, this way you can basically find out mean, median, and mode. There are functions available. I'll share these programs with you. You can play around with it. I'm just basically trying to solve this thing with a simple dictionary. You can use much complicated variable as well. So this was for mean, this was for median, and this was for mode. So I'll run this one. So I'm just copying from here. I'll go to spider. Oh, come on. Spider. I'm having a new program. I'm pasting it over here. It's giving me some error, right? Okay. I think this editor enters some special characters, and I think that creates these lots and lots of problems. And now what the hell is this? Okay. Syntax. Okay. This thing from here. Probably figure out a way. So I have the why it's giving me some error. Come on. Speak this.
On line 19, I think there should be another parenthesis.
Yeah, yeah. No, I'm not too much sure where is STR, right? Okay.
Yeah, that's okay. I think that parenthesis was okay. And I was thinking of some special type of pardon me for that. Okay, here we go. So mode is mode R5 HP is R. Okay, no problem. So let's try to change it out. Let's put a 6 here, 8 here, and 9 here. Let's try to find out. No more found. Wow, good. So what is trying to do? Okay, there's no repetition. Okay. Yes. So normally goes for the repetition or maximum, number of variables. So if I say one here, so let me check out. One can be so something like that. So we try to find more or more repetitions in a given sample of data. Okay, and I'll share these videos with you. Don't worry, I'll save this as an YNOD. Oh, come on. Okay, so this is mean, mode, median in Python. These are simple programs, not that big. Okay, now let's try to understand measure for spread. Okay, sorry, any confusion in mean, median mode?
No.
No, sir. No, we are good. Yeah.
Great. The other terminology, you can basically have a look at it and try to understand how we can answer if interview ask question. Otherwise, mean, median mode, we have a questions, we have programs also, so you know which type of methods and these things we use. Let's move ahead. Measure of spread. A measure of spread, sometimes called as a measure of dispersions. It's used to describe the variability of a sample or a population. Variability in a sample or a population. Okay. Range. Range is given as a measure of spread apart the values in a data sets are. So range from first 1 to 100, from 10 to 20, and so on and so forth. Okay. Then we have interquartile range. So interquartile range, we try to quarter it out. So we divide the given data set into 4 digits after sorting, and then how much are in Q1, Q2, Q3, Q4, and so on and so forth. So these are quartiles tells about the spread of a data set by breaking the data set into quarters, just like the median breaks in half. So quartile is more of a detailed differential breaks. The measure of spread, we already discussed this thing, right? Now here, in a quartile, type of dispersions, we are trying to basically, based on Excel sheet, how we can disperse the data. So the first quartile Q1 lies between 25th and 26th column. The second quartile means on a when you have 100 possible numbers within your Excel sheet, this is how the quartile spread will look like. So second is 50, 51st, third is 70, 76. So these type of first quartile, second quartile, third quartile. This is the kind of distribution of sampling will look like in a measure of 1 to 100 spread. So there are 100 different data entities here. When you try to understand the first quartile is 25th and 26th. That's 45 as an score. In second quartile is between 50th and 51st, and then we average it out to 58.5. Then we have 75th and 76th, and which basically average it out to 71. So this is the kind of overall quartile spread we talk about. Then we have something called interquartile spread. It's a measure of variability based on dividing the data set into quartiles. Quartiles rank ordered data set. So first you need to sort it out and then divide it into 4 equal parts denoted by Q1, Q2, Q3. Okay, and of course there's a Q4. The interquartile range is equal to Q3 minus Q1, that is Q3 minus Q1 overall. So they're trying to basically give you a difference between first and third quarter. Okay, and as you sorted out, mostly is near to the Q2, but the way it's quartile, the way it's calculated is Q3 minus Q1 is equal to IQR, interquartile range. That's the normal formula which we use in interquartile range. Then we have variance. Now variance, interquartile range. So they were just showing you how interquartile range is calculated. So we have Q1, Q2, Q3. As we have sorted it out, we believe there are 25% range is all spread it out across the sheet or across the spread, right? And then we normally calculate Q1, Q2, Q3, which is fine. And if you deduct Q1 from Q3, that's your interquartile range, and that's how you represent it, IQR. Okay. Now in variance basically the spread from number X to number Y, right? So here we normally use these formulas quite a few times. There are equations available in Python code where we use this variance as well. So variance describes such a random variable differs from its expected value. It entitles computing squared of deviations. So here we are trying to compute square of deviations. X is individual data point, n number of total data points, and x bar means of data point. Now xi, summation of xi minus x bar, square of it, and a summation from a variance from n equal to 1 to n equal to 1 and 1. To 1, and divided by the number of samples we are analyzing. And that's basically the S square. So square root of that will be our variance. So when you calculate variance, we have a okay, I have a video to showcase to you how this calculated. Let's try to understand standard deviation also. So in standard deviation, I have theta equal to 1 by 9. Okay, we have all the formulas or the standard code available for these measures of spread. So you have to key in this thing as an into your Python programming. You can just cut, copy, paste and start using it. Only you should know what is standard deviation, what is variance, interquartile range, and range. Once you know that theoretically, you can use this formula which are there ready-made mostly on your Git source base, or there are quite a few number of source sample available across Google. You can just search for, let me try to search it for you. I'll stop share. I'll open these things and I'll search for okay, let me share my, this is my Firefox. I want to say Python Python code for variance, right? Variances. And here, see, I have the Python statistics variance. So this is the code for variance. Could you see my screen, sir, madam?
Yes.
Yeah.
So here, and then there are demonstrative different data types and all those things as well. Okay, so it's that simple, and you don't normally keep typing this code. At least I'm quite lazy to type these type of codes, so you can get it copied, and they are basically self-explanatory. Means I'm on a geek site, geeks for geeks.org, and here you can see the comments are really good. They're using importing a statistic library, and then pass down a sample in was this variable name again? Is it a dictionary? Any guess?
I think it's a
It's
list,
a
right?
tuple.
Come again, ma'am?
It's a tuple, right?
Right, it's a tuple. Correct. I'm just testing you out. Sorry for that. And then we are basically passing that tuple to the statistic dot mean, and I'm just getting the mean. As simple as that. Okay. Again, you can specify the x bar when you say, when you are printing the variance. So statistics of variance they actually give you the what we are doing here, the variance. Okay, so here one for variance, the other for other functions. Means you have all these STL standard deviation. Standard deviation method name is STLD. Here we are trying to find variance, right? If you go to standard deviation, here we just replace it by STDDEV. We are using the, okay, this is for mean also. So we are just replacing this method. If you can see, and I'm share, I'll share this even I'll share right now. It's really good site. You have all these examples available to you in this one site. So that's why. Okay, let me open my presentation again. So I'll just share this site today, which is a really good one. Okay, so that's how we normally calculate these things. So don't get really baffled by these formulas. These are actual mathematical formulas and presented by many abstract to support those things. So if you want to have a look at it, you can have a look at it that as well. So let me show you this thing, a good video on range variance and all those things. Let me pause this recording first. Oh, come on.